A nuclear fuel has just entered the spotlight, one capable of withstanding extreme temperatures while securely containing radioactive material, a fuel compact enough to power microreactors, yet powerful enough to bring energy to remote locations, battlefield zones, and even future space missions. In July 2025, BWX Technologies in the United States activated a full-scale production line for uranium nitride-based TRISO fuel. This breakthrough merges the exceptional safety of TRISO design with the energy density of uranium nitride and the precision of additive manufacturing. TRISO, short for tristructural isotropic, was originally developed in the 1960s in the UK and Germany. It encapsulates each uranium fuel kernel in three protective layers, including a silicon carbide barrier that acts like a miniature pressure vessel. The result is a fuel particle that remains intact even at temperatures exceeding 1600 degrees Celsius. The concept showed promise decades ago, but commercial adoption stalled due to fabrication challenges and the global dominance of simpler light water reactor designs. That's now changing. BWXT's next generation approach doesn't just revisit TRISO, it reinvents it. Instead of uranium oxycarbide, the new line uses uranium nitride. This fuel has higher uranium density and superior thermal conductivity, enabling more efficient, compact reactor cores. And thanks to additive manufacturing, yes, 3D printing, fuel compacts can be precisely engineered with more TRISO particles per volume, better geometry, and improved thermal properties. The technical advantages are only part of the story. Strategically, this development is tied to the US Department of Energy's Advanced Reactor Demonstration Program. It directly supports the deployment of BWXT's BANR high temperature gas cooled microreactor, designed for rapid deployment in military bases, disaster relief, off grid industry, and harsh environments. This is nuclear power with flexibility, modular, mobile, and resilient. Beyond domestic applications, the potential stretches into orbit. TRISO fuels like these, especially when combined with materials like uranium nitride, could power future space missions, lunar habitats, or Mars outposts. And with BWXT collaborating closely with Idaho and Oak Ridge National Laboratories, qualification testing is already underway to ensure these fuel forms are safe, scalable, and ready for regulatory approval. Unlike traditional reactor fuel rods, these TRISO particles remain structurally sound even under severe accident conditions. They eliminate the need for massive containment systems and offer passive safety that doesn't rely on external power or cooling systems. It's a design that speaks to the future of energy security, not just in megawatt terms, but in versatility, reliability, and global reach. As the world faces increasing pressure to decarbonize, diversify energy sources, and fortify energy grids against disruption, this innovation marks a critical milestone. The ability to mass produce uranium nitride TRISO fuel opens doors not just for the US, but for the global nuclear landscape. While countries like China are investing heavily in pebble bed reactors and Russia explores floating reactor platforms, BWXT's combination of high density fuel and advanced manufacturing positions the US to lead again in nuclear technology. The question now isn't whether this technology will work, it already does. The question is how fast it can be deployed, how far it can go, and how deeply it can change our relationship with nuclear energy. If this kind of innovation excites you, hit that like button to support the channel. Subscribe for more detailed insights into advanced tech, clean energy, and nuclear breakthroughs. And tell us in the comments, should microreactors be deployed in off-grid communities?